Thank you, Amelia. Okay, let's start my session. Today, I will focus on tune the Trino. Mostly I will tune the Trino cluster itself, but I will also cover something about if someone really want to tune their queries or their tables, because I think all of these kind of things should be optimized together, and then we can get a better performance. Yes, the agenda here is firstly, I will introduce the Trino Hive metastore, because I still believe most users are still using Hive table, but probably there might be some user they migrate their data to the new data lake and the Iceberg, something Hudi, something like that. So I will give a short introduction about this kind of technologies. Then you will know how the Presto queries kind of tables and how the Presto know the layout of these tables. And the second part is talking about the SQL execution, because I believe if you really want to optimize your queries, your Trino clusters, firstly, we have to know how the Presto do the SQL execution. We need some basic ideas from there. And then the third part, I think, is the most juicy part. We will share quite a few best practice about actually your SQL queries. Some of the practice probably maybe apply to your Trino cluster. Some maybe just on your queries or change the layout of your tables. And then I will answer your questions about Trino, Presto, Hive, Iceberg, whatever, at the end of this presentation. Okay, the first part, the overview and the architecture of Trino. The Trino is a SQL engine. I think at the very beginning, we designed this kind of system. We call this one the SQL on everything. Also, we named ourselves to say Trino or Presto is something like the SQL Federation, which means you can use the Trino to query the Hive, Hudi, Iceberg. Can also query the Kafka, Druid, MySQL, Elasticsearch. I think now we have more than 30 or maybe 40 connectors in our repository. You can just configure the Trino to connect this kind of data source. The magic part of Trino is you can feel free to join the data among different data sources. Something like you can use your Hive table to join a MySQL table. I also heard someone using their Iceberg table to join their Google spreadsheet. They can use some smaller data set to do something like translation or something. There's a lot of interesting use case there. Yeah, I think at the very beginning we designed our system like we call the interactive query engine. But later on, I think more and more people are using the Presto or Trino to serve the dashboard, the BI tools, something like Tableau, like Looker, and also they may use Trino to get some quick insight about their A/B testing. I think the most crazy part here is the ETL, because at the very beginning we designed Presto or Trino as a non-fault tolerant system, which means we are not using this kind of thing for ETLs, because the ETL probably should need more safe, should be can be retried in the middle, but on Trino or Presto, if anything goes wrong, probably you need to retry the entire SQL. But some users, they just use Trino or Presto. They're performing some small or quick ETLs. They may integrate the Trino with something like a Airflow or something. They have a bunch of small queries to run, and something like to build a pipeline just by SQL. I think they can highly reduce the burden of our data scientists. They don't need to know Python. They don't need to do any programming language. They can just write SQL, because I believe SQL is the most easy language for working on the data collections. I forgot to mention that the Trino itself is an open source project. Feel free to join the community and make any contributions. Here is the GitHub link. Okay. And here is the architecture of Trino. As I mentioned, the user can use some like BI tools, Zeppelins, Looker, or they can use some JDBC connector. We can say JDBC driver to connect Trino. In this case, the Trino is more like a database, just something like MySQL. You can just make a Java program to integrate with a JDBC driver. Trino provides its own JDBC driver. You can just integrate this one, and you can configure your authentication, authorization, whatever there. Here's the one approach. The other approach is you can use the CLI. We call Trino CLI. In the CLI, you can just type in your queries. I think at the very beginning, we just use the CLI for the ad hoc queries. Data scientists just they can send their query manually again and again and got the most recent result. And on the server side, we have a single coordinator and multiple workers. Typically, we may have hundreds of the Trino workers, but there's some scalability issues. We mostly won't make our cluster too big, something like 1,000, a little bit too big. Mostly we just use 200, 400, 500 workers there. It's already good enough for most cases. I will try to explain later the relationship between the computer resource and the size of your clusters. And as I mentioned, the most use case of Trino is still querying the Hive table. So probably you need, if you're just working on Hive data source, you need a Hive metastore. Hive metastore is a separate project. It's you can download or install from the Hive project, and for this metastore, it's only maintain the metadata, and mostly the Hive metastore will use the MySQL or whatever database, PostgreSQL to store the metadata. And for the data, I mean the data you really want to read, it's from mostly I think it's still from HDFS, S3, MinIO, whatever. By looking into this diagram, we can see the Presto itself won't maintain any metadata and data. Probably we might cache some data in the middle, but I mean overall, if you are some new data or query a new table, it has to fetch from the external metadata store or the data storage. We call this design storage independent, which means you may have a better scalability at the storage part, because mostly I heard some large internet companies, they may use Presto to query the HDFS cluster with more than 10,000 nodes. It might be not a single HDFS cluster, but they can have a federation like UFS to combine multiple HDFS clusters together and query them by Presto. So each Presto cluster can easily scan maybe 200 or 300 terabytes per day. It's really a huge number of data. That's why you can see most the giant internet companies, they are using Trino or Presto to query their data warehouse, because they have their data set probably more than 10 years. I can share the structure of Hive table later, then you might see how difficult and the scale of this kind of data set. Yeah, here's the Hive table overview. As I mentioned, the Hive table, the Hive metastore stored the metadata stored in some RDBMS, something like MySQL. So they are using the database, the RDBMS table, like MySQL table, to store the metadata. And they have tables, they have partitions. They also have the metadata of their columns. So if the Presto want to fetch something from the Hive metastore, mostly I think the most frequently used operation is the get partitions by table name. So probably they may have they may construct a SQL query and probably there's a join, but I didn't look into the code of Hive metastore. I believe there might be some join. You will join 2 or 3 tables with the table name and got the partition list of this table. Probably you can imagine that if some company they have they partition their data by the dates and hours, and if they have something like a data set has been there for more than 10 years, they may have a partition list. Number of partitions could be more than 10,000. I think it's a burden for most MySQL database. So if you're maintaining a Trino cluster, you might see sometimes the Hive metastore, or we can see the MySQL, might become a bottleneck. So we have some approach to make a federation or sharding the data somehow to scale up the Hive metastore. But anyway, it's still a burden if you are querying some large tables. And as I want to mention, for the partition here, it's just a directory, it's a folder. We don't have the file list in the Hive metastore. So which means we get a list of the folders, the directories. We still need to call the list status, the list RS from S3 or HDFS. That might be overwhelming the name node or S3. So also there's might be some extra cost if you're using S3. I think probably I might miss one slide for the iceberg. I can talk a little bit iceberg from here. So for the majority use case for iceberg, they are still using the Hive metastore. But they don't maintain the partition things here. They just have some table information. They only contains a table directory, which means for the partition informations or for the file list, they just look into the folder of this table, and it will try to load this kind of metadata from a file we call the manifest. There are some other files to maintain the list of the files. So they don't need to call the IRS to the S3 or HDFS. They can save the cost of the list because the list probably super slow on S3. And also they don't need to call the name node or something. They just got the file list from the data files because the Iceberg table maintain their own metadata by themselves. So they don't need to call the Hive metastore to join the MySQL tables. They don't need to get partition by table name. They just read the partition from their own metadata. Okay, let's talk a little bit about the Trino tuning tips. Actually, this is just how the query got executed in Trino. So your SQL query is as I mentioned, it's a language. It's a programming language. So we can use the syntax tree to pass the SQL query. We can see select something from some table where some filter criteria, and there might be some aggregation, group by, limit, something. And this one will be translated to we call a logic plan or something. Something like the scan some table, and because the Trino Presto, they always show their plan in this way. I think the stage in the bottom will be the data source, where something start first, and then do some filter. They will use the result from the scan as their source, and do the filter, and do the aggregation, and do the output. But the Presto is not something like MapReduce. Here it's something like a streaming. So for the filter, it won't wait for the scan finished. Actually, it start work during the scan. So when the table scan got anything, they will just pass to the filter, and the filter will do their job. And any result from the filter will pass to the aggregation. So you can see if you really run some Trino query, you can see this first stage can start almost at the same time because it's more like a streaming. So as I mentioned, here's a logic plan. Here's some we call the physical plan or something, because we need to do some optimization because we don't have to scan everything on the table, we can scratch the filter with the scan, something like that, filter the scan. And also we can do push down some partial aggregation. We can make it run earlier. We can highly reduce the number in the for data transfer, something like that. I can talk a little bit further about why we push down the filter to the table scan can highly improve the efficiency of your query. Okay, here is the it's a SQL command actually. You can just use the explain or explain analyze inside your Trino CLI. You can use this one. You just use explain plus your SQL, and I highly recommend to use this one analyze because this one will give you the actual execution statistics. Something like how many rows it scanned, the CPU time usage, and the scheduled output or something. It's quite helpful. But we can also get some insights from the Presto UI. But I prefer to use this one because it's easily to copy this kind of result to some text file or share with others. And also, sometimes when you do some optimization, especially for some session keys or something, you might see something got changed because they might change how the Trino make the plan. You might see something different. For example, if you enable the dereference pushdown, you can see if you query something from a nested object, you can see that the data is scanned highly reduced because it skips a lot of things there. Okay. So my idea is just running your query, try different configuration, and see the difference of their plan, see the actual execution statistics, and you can do some comparison, and you can try to find the best way to run your query. So here is the more concrete example about how we do the plan scratch. Here is we have some filter. We filter out something like profile age and cities. So in this case, we may do some. We may split the filter because some of the filter can be pushed down to the table scan, but some of them maybe not. It's for now, I think that the profile, the age can also be pushed down, but I mean, many years ago, it's kind of a nested things. Probably they cannot do the scratch or the push down well. And also, I will mention later about the partition things. That might also cause you some issue because if the city is the partition keys, I think we can just push down the city when the Trino to generate the splits. And then we can make the table scan working on the profile dot age later, something like that. And okay, as I mentioned, your Hive table probably got partitioned by the data, dates, time, country, whatever. So this approach can prevent you have a super large flat folder to contain all of your data. And also, when you have some query, something like this one, you have some city, or maybe country, and if your table is partitioned by the country, dates, whatever, you can just use it. And the Presto will, when the Presto generates the plan, it will try to match the partitions exactly. So which means if you just want to query the country equal to US, it won't touch other partitions. They only load the data from these partitions. So there's some tips here. If you're running some query, always trying to make some criteria or some filter on the partition keys. You can get the partition keys of a table from the Hive meta store. You can also get it from something like show, create a table, the table name from Presto. Then you know better this table. Or you can just select star from some table $partitions. Then you can get a partition list from this table, and then you know how the table partition, and always trying to make some filter on the partitions. Sometimes maybe the partition key is not so accurate, because sometimes maybe you want to query your data by the hours or minutes, but here it's only 2 dates, right? To the day. So we can put more filters. We can put one for the DT, and then maybe there must be some other columns. They are storing the accurate data types, and you can put the 2 filters together. It can highly reduce the data scan. Okay, so using the partition key, it can reduce the number of your file to be scanned. And then for the files, it has to be scanned. Something like if you want to query the partition of US for the file 3, it has to be scanned, right? There's still some other tricks here. Try to use the Parquet or ORC files. It's more like the column-based structured data format. Why using this kind of format can highly speed up your queries? Firstly, because the data for each Parquet file, they are grouped by the columns. So which means if you check for many Hive tables, you may see for each column, for many columns, they will share the same value, something like 0, all zeros or something. So if you store the data in this way, it can make your compression much easier. And also, you can only decompose the column you need. And also in the SQL query, probably you won't need all the columns. You just want to pick up the column you really want. So in this case, you can select the column because it is stored the aggregated data by column. And also, it's not all. Also, for the Parquet files, there's a footer. So always when Trino or Presto, they are reading some data from the Parquet, they will start from the footer. And in the footer, there are some table stats, the data stats, index, Bloom filter, a lot of things, something like the min max of each column. So which means if in this Parquet file, all the ages, like for example, like we have a column called age, and for this Parquet file, if all the data for this column, the max value is 50 or somehow. So if you are query there's some query make the filter like age greater than 50, which means we don't really need to scan this file. We only need to check the footer. And then we know this Parquet file won't contain anything valuable for us. We can skip this file. So you can see if you print out some trace of the Presto reading or Trino reading the file, the Parquet file, you can see most of the files, they only touch less than 1% or 2% of data because they are using the index, they are using the stats, they can skip most of the data in this file. Okay, so here is the Parquet file. The other advantage of using Parquet file is the current local cache, I mean the caching service in the Trino or Presto DB, they only support ORC and Parquet. It's kind of structured data. Because if you're using CSV or JSON file, it's row-based. It's always scanned from the very beginning to scan the entire file, passing the entire file. You can see actual costs, and also you cannot use the local cache of this file. Okay, actually, Alluxio is working on the local cache for both Trino and Presto DB. We call it Alluxio SDK. Feel free to give it a try. Now I think in the Presto DB side, we call it RaptorX, sometimes in some blogs. But on the Trino side, I just sent out a PR about the implement Alluxio SDK to Trino. Okay, so if you have local cache, which means for most of the file, you can only cache the footer. It's a super efficient caching solution. Here is just an example. It's not a formal benchmark. You can see if we enable the predict push down and we something like because I just make some fake data. I make a month called 13 because that's the only row has a month with 13 because it is fake. So you can see before the push down, rows scan 2 million rows. After this still push down to the table scan to the partitions. They only scan 1 rows and the input data is just 500 bytes and previously it's 200K bytes. I just want to use the example to show it's super important. So which means trying to use some filters on partition keys and also trying to use some filter in the packet file can know better which data can be skipped. Then you can highly reduce the number you scan. You can save a lot of your egress cost, and also it will improve the cache efficiency because you don't need to cache all the data. You only cache the data you read. And here's the thing. As I mentioned here, the packet file is always read from the end. We read the footer first. I think it's okay for HDFS, but for the S3, because the S3 API mostly it's optimized by loading the entire object, or they can skip forward, but it could be difficult to skip back or seek back. So you can specify a range, but in this case, you just load the data, the last part of your packet file, and you need to seek forward, backward to get some other data. So in this case, I have to say that the S3 API is still efficient, but sometimes it will give you more trouble if you really want to. You can see that if you are using something like this one, the HTTP APIs of S3, probably you might see some performance degradation if you just compare with the on-prem HDFS. That's why our Alluxio is deliver some cache called Alluxio cache. You can use the HDFS API, just connect to the Alluxio, and Alluxio can cache your data from S3. Sometimes it can improve performance, but it's not always true. It still depends on how you use your data, how you run your query. If you use a packet and your query is very selectively, I think this one might help. You can use some cache like Alluxio using the HDFS compatible interface rather than the HTTP interface. Okay, let's go to some best practice about the running the Trino, or we can say construct your query, optimize your table, something like that. The first thing is, I might forget to mention mostly our Trino cluster, they put everything in the memory. As I mentioned, it's more like a streaming. Even though there might be some SSDs attached to the Trino cluster, but mostly we won't do data spill. This means we won't store cache the intermediate results to the disk. So everything is in the memory. That's why the Trino is super fast. And so sometimes the memory might become a bottleneck. So especially when you are running some query in parallel. In this case, you may find some we call it memory allocation dialog. You can see you have maybe 20 queries, they're all running, but none of them got any progress because every of them needs some more memories, but the memory is full, and none of them can get more resources, so they just stuck there. In this case, there's quite a few approaches. The first thing is most easy, you can set the max memory per query. You can limit the memory of each query. But that might make the user of Trino feel really bad because they won't give you the answer immediately. They will fill your query after probably maybe 10 minutes or even 1 hour, 2 hours. Then the Trino say, okay, your query is out of memory. Then they cancel their query. It's super frustrating. And we can also put some max memory per node. I use this one a lot, actually, when I was working for Twitter. So I think the second one can reduce the chance of the allocation dialog, make the max memory for each node to be controllable. But again, it's still not the best choice, and it will kill some running queries. So I prefer for some high SRA Presto cluster, I prefer to set the max concurrent value, which means we limit the max number for concurrent. We can just put some restrict something like 20 or 30, which means for each Presto cluster, we can only run 20 query or 30 query in parallel. And then we can give each query more memories. Then we can improve the success rate of each queries. But there's still some trade-offs there. So the other approach is we can just trying to give the more memory to each query, but if there's some dialogue happen, we can ask the low memory killer kick in. This one will kill the query, long running query with using the most memory resource. Then they can release some memory, but again, it will kill some users' query. They may complain, but it's still better than make the deadlock. Am I right? Also, I think I forgot to mention here is you can also use the reserved memory to avoid the dialogue. But the thing is, by default, the Trino will use half memory as the reserved memory, which means if the dialogue happens, it will use half of their memory, the reserved memory, to run some query to guarantee there are some progress. They can fix dialogue. But the thing is, it will highly reduce the total throughput of your Trino cluster, because mostly they're just using half of your memory. Anyway, there's just some trade-offs. You can try which one is better for you. I think I already mentioned I prefer to use the columnar data format like a Parquet, like aux, and I think last time I do some benchmark, I'm still seeing the aux might have a better performance than Parquet on both Trino and Presto DB, because the Facebook is using aux. There's a lot of guys that are trying to optimize the query on aux for a while. There are some contributors focus on that. But for the Parquet, I think there's a lot of open source users, but they may have less contributor. I don't know. But anyway, maybe I'm wrong. Maybe just for some particular query, OK is faster. But I'm still recommend Parquet, not for performance, just for the usabilities, for the support, and also I think most open source users, they are using Parquet. Avoid using CSV and JSON format, and enable the compression. I recommend the snappy, because this may have the less CPU consumption, because mostly your Trino or Presto cluster is CPU intensive. So if you get some ideas of your Trino, it's CPU intensive, try to use the snappy. If you think it's not CPU intensive, it's IO intensive, you can try to find some better compression to save the IO bandwidth. And also you can just use the partitionings. Every time create a table with some better partition keys, and also you can use the bucketing for your Hive tables. I think the partition bucket just means that you don't really need to scan all the data files of your table. Okay, so for the Hive tables, I think the Iceberg table it's already there. They have some stats, but sometimes the data might be missing. You need to check with the maintainer of your Hive store. So you can do the analyze table command, and they'll give you some insights of your table. How many rows there in the table, the max, min value, whatever there. It can be more or less. So this kind of stats can help Presto or Trino to make your query plan to be more efficient. I think that's something I would like to mention in the next slide. So for the drawing, okay, so for the drawing, mostly I think now that the CPU in Trino it's very mature. You can just it's already enabled by default. You can just use it without any burden. And so I might recommend you just make Trino to do the job. You just enable the CPUs. But in case your Trino administrator disable the CPUs, you can try to optimize the query manually by yourself. You can just make the we call large left, which means your large table on the left join a smaller table. If the something like select something from a large table, join some small table or something. And also about some large table join small tables, you can also set the distributions. You can do some hash join or broadcast join. Again, just let Trino do the job. Mostly you don't really need to think about it. But if you really want to do it, you can try it, and then you can go back to use the explain, analyze to see if there's any difference of your query. Sometimes it may make your query better, sometimes maybe make your query worse. And also the other strategy is just, as I mentioned, large table on left. So if you enable this one, you can put it atomic, so they can always automatically, you can always try to do their best to optimize your query. Also, if you're just talking about the Hive tables, you can also enable the dynamic filter. It's also enabled by default, but the key is it so depends on how selectivity is of your queries. So which means by enable this, you can reduce the data amount from the table scan to join. Okay, here's something I think I already mentioned. Because sometimes the Trino or Presto, their storage is independent. So they might be always fetching data from the outside, from S3, from HDFS. If someone is using something called co-located, which means they deploy their Presto with their HDF data node together. For each node, they will deploy both Presto and HDF data node, and they may have some data localities, but that's not recommended by us. I still believe we should separate the computer engine and the storage. We need to scale up and scale down the computer and the storage separately. So if we separate the storage from the Presto, which means sometimes it may be far away in another data center, or there may be on another rack, or be far away from your Presto, so you can put some cache. The first level cache is we call the local cache. Actually, the official name is the Alluxio SDK. They can cache their data just on workers SSD. As I mentioned, mostly you attach SSD to the running Presto cluster, but Presto is not really using it. They don't want to do the data spills. So sometimes you're wasting a resource. So you can just take advantage of your local SSD as the local cache. You can enable it. I think for the Trino, they have a project called RubyX, but this one is not actively maintained, and also there are some security issues there. So now I'm working with the Trino community to deliver the Alluxio SDK from Presto DB to Trino. And but the thing is, the local SSD of your Presto cluster might be still too small. The capacity is still limited. So you can use a second level cache, we call system cache. You can have a distributed cache. You can deploy 100 or 200 nodes, have 100 terabytes or even more cache space, and you can cache your packet and the aux from the HDF3, and the Presto or Trino can just hit your Alluxio. Especially when you are using S3, I think this approach can highly speed up your query. Okay, here's some general configuration of your Trino clusters. There's also some common mistake I have seen in the recent years. Firstly, don't make your cluster too big. because that's a real story. When I was working for Twitter, someone from some other team, they are trying to because they have their some own resource, uh, they scale up. I gave them a private Presto cluster. They scale up their Presto cluster to 1,200 workers. It will make the coordinator failed frequently. The coordinator becomes bottleneck. But at that time, that's still Java 8. Now I think the efficiency of coordinator will be much better, but we still need to keep in mind, don't make a super large Trino cluster. That might cause some issue on coordinator side. I think for the second one, that's true for Presto DB, but that's not true for Trino now, because Trino is now using the Java 17. So that's the only choice. I can run the Trino on Java 18 actually. It's no issue, but you cannot use the 11 or 8 anymore for Trino. Maybe you can hack a little bit to enable the Java 11, but that's meaningless. And try to use the G1 GC. Someone maybe want to try to reduce the GC latency. They are using some JGC or something else. I tried actually when I was working on some Presto cluster. They want to provide the sub-second level queries. I tried the JGC. We can see that the GC powers are highly reduced, but the GC times are highly increased. So the total throughput of your GC, I think it got reduced. And I cannot have apple-to-apple comparison because they are running different queries with the G1 GC clusters. Yeah, the last two is actually I just recommend don't overtune your JVM. Just let the JVM do the jobs. Keep the default values. If you got something with GC or memory issues, just give it more memory. You can fix most of the issues. Memory is cheap. Okay, I think that's all I have today. Now we have the Q&A session.
Wonderful. Thank you so much, Beinan. And we have a lot of questions here. We're going to try to go through as many as we can. But just a reminder, in case we run out of time, we encourage you to join the community Slack channel. It's on alluxio.io/Slack. And Beinan and our colleagues are there often answering questions. So don't hesitate if you did not get your questions answered here, do join our Slack channel. All right, so our first question here is, can we use Trino for a data lakehouse implementation, assuming there's a legacy data warehouse and a data lake on AWS S3 or GCS is hosted?
Oh, that's a really good question. I think both Presto DB and Trino community, we are trying to work with the data lake, something like Iceberg, Hudi data lake from almost, I think more than 3 years ago. We are trying to do that. Now, I think we already implement the read and the write path with this kind of thing. But again, I still recommend to use the Presto as the read only query. But I guess that the most of the Trino committers may say they're very good for right now. But we have other choice. We can use Spark. We can use something else for the ETLs. I still prefer to use Trino or Presto to read the data. But for some small jobs, some small ETL, for some small data migrations, for some small injection, whatever, you can just use Trino. I think it's okay. But we are talking about some query running there for 10 hours. Probably you might need Spark or something else because the Trino is not fault tolerance.
Great. Our next question here is the stats in the footer different from the stats from analyze table? And the follow-up to that was, is the stats from analyze table stored in Hive database?
I think the folder you mean is the partition. Am I right? So I think for the newer version package, we have some stats for each partition folder. We call the package summary. That's a really new feature. I'm not sure about Trino, but on Presto DB side, we didn't get a chance to look into it to integrate with this kind of stats. But this will be super helpful. As you mentioned, it can provide a folder level stats. It can help you, just to skip more files during the query. But now I think it's too new. It's too new for Trino and Presto. But I can double check to see maybe Trino already support that.
Great. Our next question is, can we use Trino for both ACID or OLAP type workloads?
We can, for sure, we can. I heard a lot of use cases. They are using Trino as a real-time database. Also, maybe some other users are using Trino as a sub-second. All the queries should be finished in 1 second. But in this case, we can also to make some guarantee about your transaction. Something like if you're using Iceberg, the Iceberg itself, they can give you a snapshot level isolation, which means you can commit your something like the update of your query, and other users won't read the uncommitted data from you. I think it's super promising. Now I think I recommend to use Presto just like a normal database. It can handle everything for you. But in case you don't have other choice, if you have some other choice, you can try some other things. But if you just have Presto, you can try to use Presto to have some transactional queries to update the tables. Also select something with the frequently updated table. It works, especially for Iceberg and Hudi tables. But for the Hive tables, there might be some limitation because there's no guarantee. There's no snapshot level isolation.
We have a legacy MS SQL server that is accessible via Trino, but we noticed that there are long delays as opposed to accessing data directly from MS SQL. Can we leverage Alluxio to speed up the access in this case?
For the MySQL, that's something different. I know this connector, but I never touched this connector for years. This connector is quite simple, so which means it's more like something like a SQL translator. It will translate the Presto or Trino SQL to MySQL SQL, and there's some probably just one node or something will push down. Actually, just send the MySQL SQL to MySQL, which means actually they still the MySQL do the job. It will fetching the data to you, and in this case, it might be difficult for Alluxio to kick in to catch some data because I think the Alluxio can provide a better role just in the middle of your Trino and HDFS or Trino or S3 rather than the MySQL.
Great. And would you recommend using Trino federated queries for real-time use cases?
Oh, this one is really good one. I try this one. Just because a lot of optimization has to be in the same connector, which means has to be in the same data source, like Hive or Iceberg. So if you are using something join the Iceberg table with Hive, some of the optimization might be not able to kick in. So you might see the data you scan or the draw efficiency might be worse than you join the two tables just in the same connector, just in Hive or just in Iceberg. You can see the difference, but that's still case by case. For some query, that should be the same because they don't have any optimization can apply to this connector. But some of them may highly rely on some optimization just within one connector.
Great. Our next question here is, how is the performance of Trino with multiple joins? Is it good to directly use the multiple join query for a BI dashboard backend?
I have seen quite a few data scientists, data engineers, they just running some super big query. They may have 300 stage. They join 20 or 30 tables together or something. It's working, but if you're talking about dashboard queries, I assume your dashboard should be show up or the query should be finished in a couple seconds. In this case, that's really difficult for Trino to fetch results for you.
All right. Is the default max memory per query and max memory per node good enough? Or how can we tune max memory per query and max memory per node?
I can give some hint about how to optimize some max memory per query. I'm just using, firstly, I will calculate the total memory of a Trino cluster, let's say 100 terabytes. And then we can calculate, we can then maximum concurrency. That may be just based on your experience. You know that the concurrency of your Trino cluster probably will be 100, and just make your total memory of your Trino cluster divided by the maximal concurrency. Then you got a value 1 terabyte. That should be the safest the value for the query, the max memory per query. But you don't have to do that. You can double it, maybe triple it, because this might be not possible to all the query reach the maximum memory. So you can try to increase its number until you are seeing more dialogue.
And here we have, is there a recommendation on partitioning related to the table size? After partitioning, is there a recommendation on optimal size of partition parquet file size?
Oh, that's really a good question. Here's the thing: if you have more partitions, maybe multiple level partitions, or you can see the table scan, the efficiency of table scan might be improved because you can scan less file. But the thing is, the SQL planning might be more tough to train on, because during the scan, maybe your number of files and number of partitions may be hundreds of times bigger than before. It will cause an issue. You may see some planning might be failed. So you need a balance here. That still depends on data size of your tables, and also how strong for your Hive store and how strong for your Trino coordinator. You need to have a balance. You cannot just have too many partitions, but you can also don't want with just one partition. You need a balance.
Great. Our next one here is, how do permissions for Presto, Alluxio, and S3 work together? How can we ensure that a user can only access permitted data when using Alluxio as a cache for the data persisted in S3?
There's quite a few approach for this one. Firstly, you can use Ranger. Now I heard a lot of Trino users, they just use Ranger. This is a third-party security plugin. You can just have a fine-grained access or permission control on each table. I think that's really cool. The other is the default way, just something like a Trino HDFS, because there's no built-in access control. I mean, the table level or the file level access control in Trino. So we can just relying on the access control from the file system, like Alluxio, like HDFS. So the security model of Alluxio actually is very close to HDFS or POSIX. You can just based on the group, the owner of each file stored in the Alluxio to do the permission check.
Great. And we have a follow-up question here to the earlier MS SQL question, which is, would you recommend replicating the MS SQL server data to Iceberg then? Or maybe I misinterpreted that.
I'm not sure. For the Iceberg table, I think you're asking to join the Iceberg table with the MySQL table, or you want to use the MySQL to store the metadata of the Iceberg?
Edward, why don't you submit a follow-up to that? I might have misinterpreted your question. In the meantime here, there are a lot of great kind of in-depth questions. For folks who are newer to Trino and Alluxio, what's the easiest way to get started with Trino and Alluxio?
Oh, we just have a demo. I think we just have a demo with Trino community. We are trying to integrate with Trino, Alluxio, and Iceberg, these three together. There's a Docker compose. I think we can post the link to our Slack channel later. And we can. There's also a blog. There's also some videos. Many thanks to the work from Brian Olsen from the Trino community. We are working together for this kind of thing. I think you can just use the Docker compose. You can start your Trino plus Alluxio cluster immediately.
Wonderful. And I think we have time for one more question, which is, how can we make large left in a plan? I think this was earlier on one of your slides. You had large left.
Large left. Large left means we put the large table on the left, and in case the right table is small, we can see the difference in the plan. Probably the Trino will broadcasting or dispatch the small table to all the workers. So which means for each Trino worker, it will try to streaming the large table and keep the small table in memory or somehow, then they can do the join. I think that's the probably reach the best performance for join.
Super. And I know there were questions we didn't have time to get to. I just want to mention two things. The first is please take this chance to just scan the QR code on the screen. This is a short 5-question community survey, and you will automatically enter a chance to win our raffle. We do this once a month, and this greatly helps us get feedback from the community as well. So please do take a minute to do that. And then again, if your question didn't get answered, please do join us on the Alluxio community Slack channel, which is also posted into the chat box at alluxio.io/Slack. And you'll find folks like Beinan and myself and the team there very actively engaging with the community. So that's it for today. Thank you again, Beinan, for this wonderful session. And the recording and the slides will be sent out post-event. And we look forward to seeing you guys at next month's office hour and webinars. Bye. Take care. Thank you all.